Hello guys, welcome to my channel. Today's video is about making a singly linked list in Java. If you have not subscribed to my channel, please subscribe. Thank you. Singly linked list. This is a simple data structure. Dynamic memory allocation. Total memory required is O(n). N is the number of elements required or stored within the linked list. Linear container. This is a linear container and we iterate from head to the end of the tail of the linked list. Linear traversal to access any arbitrary element. The complexity of accessing an arbitrary element is O(n). Efficient addition and removal. This is O(n) in worst and average case. O(1) is best case. It happens when we are inserting or deleting from the head of the linked list. Singly linked list only forward traversal. There is no backward traversal that can be done, but the complexity will go to O(n) square because we have to store into another list and then traverse. Thank you guys. Let's code. Hello guys. I have created the project, added two classes, one for the node and the other for the list. These are empty classes and I'm going to write the code for these two classes. I have completed the tester class. This class we will use these tests to validate our functionality for the singly linked list. Let's begin the coding for node and list class. Okay, we are going to store integer data. So private int data private node next. This is the reference to next node object. Okay, we simply need a constructor and next is equal to null. Another public node int data. This dot data is equal to data and this dot next is equal to null. Okay, getter setter methods. Public int get data and set method for data. Public void set data. Parameter and one setter getter for the next. Public void set next. Node next. This dot next is equal to next and one getter. Public node get next. Return this dot next. Okay, this is simple class. Two data fields, two constructors and two getter and setter method for the data and the next node. Okay, now let's go to list class. So we need head, linked list head, private node head, constructor to start to initialize empty list, public list. This dot head is equal to null. Let's keep track of number of nodes. Private int count. Let's initialize it to 0. Okay, so what we need: add first, add last, remove and print and size. Size is a simple function. Public int size, return count. We simply return the count of elements. And print function, public void print. Okay, if the list is empty, let's write empty function. Public boolean is empty. Return head is equal to null. A simple function. Check empty list. Now if this dot is empty and we print the list is empty and return from here. Okay, now if the list is not empty, we print. So node current is equal to head. Iterate is not equal to null till the last node. Okay. S out, and let's make it formatted output. So percentage minus percentage 10 minus 10s 10d. Okay, now print the number. Let's make it 70. Okay, current dot get data. Okay, iterate to next. Current is equal to current dot get next. Okay, print the new line here. Okay, I think this is enough. Now let's add first. Public void add first into value. Create new node. Node is equal to new node and value. Okay, now if it is empty, if this dot is empty, we simply store it to the head. Head is equal to node. Else list is not empty, but we need to insert at the front of the list. So what we will do, we set the next node of the node as head and store it on head. So node dot set next head, and head is equal to node. This will point to first node. Okay, increase the count to keep track of the number of elements. Now insert at the end of the list. Public void add last into value. Create node. Node is equal to new node and value. Now if it is empty, insert at head. If is empty, so we will insert at the head this dot add first and value and return from here. Now if the list is not empty, so what we will do, node current is equal to head, and we navigate to the last node while current dot get next is not equal to null. So what we will do, current set current dot get next, and okay, we reach to the, this will stop at the last node. Okay, now current dot set next node, store at the end of list, increase count. That's it. Okay, our two functions are done. These are the main adder functions to insert the new node at the front or the last of the linked list. Okay, now the remove function. Remove function is very important function. I take care of three things. Public void remove int value. Okay, case 1, if empty, if this dot is empty, list is empty, return. Okay, now list is not empty. Case 2, head node. Value is stored at the head node. If head.getData is equal to value, so we simply store the next node to the head. Head.getNext and reduce count. Next, somewhere between or at the end of the between or end of node, or maybe it is not there. Node current is equal to head and pre is equal to null. We keep track of the previous node also. While current is not equal to null, iterate till the end of list. Okay, if we found a match, if current.getData is equal to value, so what we will do, we set the next pointer of pre node to the next pointer of current node. Pre.setNext current.getNext, that's it, and reduce the value count minus minus, break the loop from. So navigate. So pre is equal to current, keep track of previous node, and current is equal to current.getNext, move to next node. This is how we will navigate. Okay, this is done. Linked list is very simple data structure. It is linear and runtime is mostly n. N is the number of elements. addBack. Okay, change the method name. Add first, addBack, and addFront. Okay, this is addFront. Okay, now let's test it. We simply run this. This is our list. Okay, so we started with add 4 at the back, so there is only one element in the list. Then add 5 at the back. 5 is inserted at the end of the list, and there are 2 elements now. 6 at the back, so 4, 5 and 6. 6 is the last element. We have 3 elements in the list. Now we inserted 3 at the front of the list, so 3 comes here. Then we inserted 2 at the front of the list, 2 comes here. Then we inserted 1 at the front of the list, so it becomes 1, 2, 3, 4, 5, 6. 6 elements in the list. Now we are remove 1. 1 is removed from the front, and remove 6. 6 is removed from here, and remove 4. 4 is here, and it is removed from center of 2 nodes, 3 and 5. Same way, 3 is removed, and then 5 is removed. Then 2 is removed, and the list becomes empty. This is how we can test the functions of a linked list, and linked list is tested properly. And linked list is very simple data structure. Thank you guys. Please subscribe to my channel and promote the content. Have a good day. See you in the next video.